Welcome to 42nd lecture in the course of Industrial Engineering and Operations Research. We are discussing transportation models. In the last class, I told you about transportation model, that where you have some destination, let us say m number of destinations and n number of maybe suppliers. So, suppliers supply the goods to destinations, and every supplier has some capacity to produce and every destination has demand. How to transport items in an efficient way? Unit cost of transportation may be different for different combination of destinations and supplier. So, therefore, you have to allocate the units in such a manner so that the total cost is minimized. I also mentioned that transportation model which we define is basically a linear programming problem, and we can write the objective function. Objective function is the minimization of the total cost, and decision variables are that number of units supplied by one particular destination to other. So, suppose there are 5 destinations and maybe 3 suppliers. So, total 15 combinations are there. So, you can say that basically 15 quantities, that means units supplied by one destination to other destination is basically there are 15 variables, 15 decision variables. Out of that, some may be 0 also. In fact, most of them will be 0 and something will be there. So, we can write objective function, and constraints are also there, that you know that we know that a particular factory can produce only this much thing. So, you know that if we supply from that factory some things, okay. So, that will not exceed the capacity of the factory. In fact, it will be equal to the capacity of that factory, like that. Similarly, demand will also be properly balanced. So, we can solve that problem by linear programming problem by simplex method, and we can use any software, but a special structure of the transportation problems makes it easy to follow another approach which is more efficient, and here we will be discussing that, but we have to almost follow the same procedure like in simplex method. We obtain a basic feasible solution. So, here also we have to make a basic feasible solution. So, by basic feasible solution we mean that there will be, suppose there are, let us say there are m suppliers, m supply factories and n demand centers, okay, or distribution centers. So, m plus n minus 1, you have to allocate the materials in m plus n minus 1 cells. That means, these will be basic, this one. Some basics variable can be 0 also. So, today we will be discussing one method to obtain initial basic feasible solution. That means, today we will not optimize it fully, but we will only obtain the basic feasible solution by some one method, and that method is called northwest corner method. So, let us discuss that, and it will be better that if I discuss it through the example only, then you will understand it very nicely. Later on, at the end of the lecture, I will also tell the steps in language form. So, some special items are produced at factories at Patna, Guwahati, Mumbai and Hyderabad. These are the cities. Distributors are located at various cities: Lucknow, Delhi, Jaipur, Chennai and Kolkata. Supply and demands of items are indicated in table. Note that factories have capacity to produce 18,000 items, but only 15,000 items are in demand. Transportation cost of each item is proportional to distance it travels. The road distances from factory to distribution centers in kilometer are indicated in each cell. Your goal is to minimize the transportation cost. So, these are the distributors: Lucknow, Delhi, Jaipur, Chennai, Kolkata, and these are the factories. So, Patna. So, Patna to Lucknow, if you know, I have indicated distance in kilometer, that means 610. So you can consider that, okay, let us say 1 rupee per kilometer you have to pay transportation charge for transporting 1 unit. Then if you transport that 1 unit from Patna to Lucknow, you have to pay 610 rupees. Okay, but we need not worry about that. Basically, we will allocate in such a way so that the product of unit into distance will be minimized. Okay, I can consider it rupees also, but this is basically distance between Patna and Lucknow, that is 610. Distance between Delhi and Patna is 1060. Distance between Hyderabad and Kolkata is 580. Distance between Hyderabad and Delhi is 1000. Hyderabad and Kolkata, distance between Hyderabad and Kolkata is 1500. Okay, distance between Hyderabad and Lucknow is 1300, like that. So this is distance between Hyderabad and Chennai is 630. Okay, so like that these are there. Okay, so you can consider them. These are the unit cost of transportation. These distances itself are unit cost of transportation. Supplies, that Patna supplies 3000 units it makes, Guwahati 6000, Mumbai 4000, Hyderabad 5000. So total units made by the factories in a combined way 369, 413, 518,000. And demand is that Lucknow needs 2, Delhi needs 7, so 2, 7, 9, 413, 14, 15. So 18,000 is the production and 3,000 and 15,000 is the demand. So that means 3,000 is there. So 3,000 will be the excess supply that will be unutilized, but we make a dummy destination. We say that is dummy. You can say it is a dump yard, okay, or whatever is that thing, that I have made extra column dummy, and that dummy needs 3,000. Then it, in that case this will be totally balanced. Okay, so this is what that, now this is balanced. Now we have to allocate that maximum amount to these units. That means we have to give one solution, and that solution will be feasible solution. It is called basic feasible solution. So we have to start with northwest corner. Which is northwest corner? Lucknow to Patna cell. This one, it is in the northwest side. Okay, this is in the northwest side, because you see that this is the north direction, this is north, this is south, this is east, this is west. So this is northwest, this is NW. So this is the maximum northwest corner. This is the northwest corner. So what is the first step? That you have to allocate as much as you can in this one. So in this cell, what amount I should allocate? Patna produces 3,000. Can I put 3,000 here? No, but then Lucknow demands only 2,000 only. So I cannot put 3,000, I can put 2,000. So out of the supply and demand, whichever is the minimum, that much I can do that. And in order to indicate, I can make something, I can write this thing in bracket 2,000, because otherwise I should not confuse with the unit cost. 610 is the unit cost and 2,000 amount I have allocated here. So this I did in the northwest corner, and then I have fulfilled all the demand of Lucknow. So I can strike this. Okay, I can strike this, and so Lucknow, we cannot give anything now to Lucknow. Its purpose is solved. We can, but still that I have to, and here I can adjust this supply to 1,000, because 2,000 I have taken. So now Patna has Patna factory has 1,000 remaining item. Now so I started from northwest corner, and I either have to go this side or that side. I cannot go down, because I cannot give anything to Lucknow, but I can move towards Delhi side. So that means remaining 1,000 I can assign to Delhi. So I can put it here in bracket something 1,000. So therefore this is also balanced. Now this portion Patna will be also striked, okay, because this is now there is a 0, okay, and here it is 0. So, that way, so let us go slowly, let us see that what I am doing. So, I assigned 610 to Lucknow, this one Patna Lucknow cell, and since Lucknow's demand is totally fulfilled, so therefore now this demand is 0, other demands remain same, and this is strike off. This is striked off, so that means this is going like that. Now let us say that so this is basically struck, and now here go to this one next. So step 2. In step 2, what I did, as I told that I cannot give anything now to Lucknow, but Patna has 3000 extra thing is there. So I go this side and see Patna has 1000 extra. So that entire 1000 I have given to Delhi, and now Patna's story is finished. Here this is like this, and Lucknow is also finished. So therefore now we will not give anything here, okay. Now what we will do after we have already allocated here, so we will come down, okay, because we cannot go towards left hand right hand side, so we can only come down, okay. There are only 2 paths to go, this way or that way, that is already this one. So here we will come down, and now we have to give that 6000. So what should we do? That 6000 is the supply from Guwahati, and Delhi also demands 6000. So both, so therefore what happens, that you will give that 6000 here, you can give maximum 6000, and now what should I do? That you can either strike Delhi or you strike this one Guwahati, but actually you may think I can strike Guwahati also, I can strike off Guwahati because Guwahati's location is complete, but that one can do that, but that is not proper, because we need to have basic feasible solution, and we need how many basic variables? M plus n minus 1. That means there are 4 cities, Patna, 4 suppliers, and this and including dummy, how many is 4 plus 6, 6 destinations minus 1. That means 9 cells should be filled up. So you have to do that. So some of them may be 0. So doesn't matter. You put 0 there, but it is better. So better, best practice is that I would not have, I strike suppose 1 arbitrarily, any one. I did like this, Delhi, and remaining then I move this side, because I cannot come down. I have to move towards right hand side. But I saw that since I had given 6000 amount here, that this is 6000, so this is already 0 is remaining, here 0 is remaining, and here also 0 is remaining, because 6000 minus 6000. So here I cannot allocate anything, but I still put 0. So it is a 0 basic variable, and this is called degenerate basic variable, because when you get any basic variable, even one basic variable 0, that is called degenerate, but it is convenient because those many basic variables are needed for solving the problem in the later step. So right now you can put that 0, okay. If you confuse that with 0 in bracket, then many people write instead of 0, they in fact write this one epsilon, okay. They don't write 0, they write here, allocate here epsilon, but with understanding that epsilon is basically almost 0, it is very small quantity, that doesn't matter. So that way they do that, correct, fine. So that is what this one. So let us go to next slide, what I have done in step 3. So in step 3 you see I allocated 6000, but you see that in somehow in the solution maybe that I generated maybe with some software, or maybe with my teaching assistant person, whatever is the thing, but somehow he has struck of both the things, that he had made that cost Delhi also and Guwahati also, okay. What I suggested in my previous slide, that it is better that you only strike of only 1, so that in remaining you can just put 0, okay, so that you will have this one, but he has done that one. So, as far as if your goal is only to find out a basic feasible solution by northwest cardinal method and answer is only this, so it does not matter also, it does not matter, but later on for solving again you have to put some 0 at some places, maybe you can again identify some cells and in that you put 0 0 because you have to make. So, anyway that it is struck here, so it is struck up here. So, this line is gone, this line is gone. Now, what you can do that you can actually allocate, I would have done 0 here, but you can if you are not. So, I put out 0 here, then I will naturally I may have tendency to put 11 some amount here in Mumbai Jaipur cell, and how much I again can put 4000. Again I have to that 4000 if I put, I can either remove Jaipur from this one or I can remove this one. So, arbitrarily you can remove anything, okay, but not the both, but maybe let us see in the step 4 what you know that my assistant has done. Maybe he has done struck here, he allocated 4000 amount here, and by allocating 4000 amount here, Jaipur is also gone and Mumbai is also gone, okay, fine. So, therefore, allocation point of view it is okay, but in remaining cell he has to put when optimization is needed for means final procedure, then that time he has to put some 0 value somewhere, okay. So, right now it is 4000, that is okay, but sometimes the exam problem may be only this thing that find out the total cost of transportation by transportation method. There if you remember 0, epsilon etc. are not, that does not matter. So, this is like that. So, this is gone, and now you have come here. So, now you have to allocate, now this is 5000 here. So, you will go to this one is available. So, maybe we can put 5000 here, and if you put 5000 here, then what will happen that it is no, you cannot put 5000, demand is only 1000 here. So, naturally you can put only 1000 here, right, in this one, that Chennai needs only 1000, although Hyderabad is producing 5000, and here Kolkata also needs 1000. Sorry, this is different, okay, I need not have, why I am striking 630, that is not 630 is the unit cost of transportation, you can say, okay. This is basically 1000 in bracket, and here also I can give 1000, okay. So, that Kolkata's demand is complete, Chennai is also complete, Kolkata is also complete, still Hyderabad has surplus capacity because it is 5000. So, remaining 3000 will go to dummy. That means it is simple way that Hyderabad will not be able to store will not be able to sell extra 3000 units, and those will go down, okay. So, he will just put in the go down. So, this is what it has done, and now let us let us see that what has been done. So, in the next step we got this type of situation that here 630, 1500, 0, and we are having 5000 here. So, we have now given 630, 1000, okay, that is as I told that you see, but and then remaining capacity is 4000, okay. Then we have given 1000 to Kolkata, remaining capacity is 3000, that means Hyderabad still has 3000 unit. Then what happens that here, that you know that Hyderabad has 3000 unit here. So, it is basically 3000 has to be given to dummy. Given to dummy means dummy is not anything, that means it will be just put in some go down, it will become inventory of Hyderabad, that is what. So, this is 3000, now everything is 0 0 0. So, you got one initial basic feasible solution by northwest cardinal method. That means you are supplying this way 2000, wherever nothing is there in the red letter, that means there is no supply is there, that means from Patna to Jaipur nothing has to be supplied, from Patna to Chennai nothing has to be supplied, from Guwahati to Chennai nothing has to be supplied, okay, like that. So we have got this one. So we have to supply only Patna to Guwahati, Patna to Delhi, like that. So how many cells are there? 1, 2, 3, 4, 5, 6, 7. But by total only this one 7. But we need, where there are 4 suppliers. So 4 plus destination is 6 minus 1. That means 9. So 2 cells are basically needed more. So I can supply 0 quantities to those, so that my procedure becomes complete. But you know, if I, so you see that here the final table has been given by northwest kernel method. So how it has been given? That here, that as it is shown, that this should be your initial supply arrangement. That's what the method. But it is naturally, it may not be optimum, okay, because we just started from northwest kernel and this is the thing. And maybe that in order to complete here, maybe I would have done, maybe I would have supplied here 0, and maybe I would have supplied here, this is, then I have done here, then suddenly I am jumping. I should go step by step, it will be convenient also, that you know, I go from here, then I go in north. Started from northwest kernel, by arrow I went 1 step, then I went 1 step, then 1 step I went here, but here I could not supply anything, only 0. Then I took a turn here, then I went here, this is like that, and then I can come here horizontally and give 0, then I come down, okay, arrow, and then you can, I come here, here, like this, okay. So this is way, that is the thing. So you see that nice staircase type of pattern also has come, that, so that 2 people are getting, that means Guwahati to Jaipur, you have to supply 0 quantity. In fact, Guwahati to Chennai also has to, you have to supply 0 quantity. But what is the difference? In my mind, okay, I am thinking that Guwahati to Chennai supply is 0 because that is non-basic variable, whereas Guwahati to Jaipur is a basic variable. So you see that Guwahati to Jaipur is a basic variable, Mumbai to Chennai is a basic variable, but its value is 0. Mumbai to Jaipur is a basic variable, but its value is 4000. So this is a degenerate basic feasible solution. So we say degenerate basic feasible solution. Feasible because it is feasible only, we are not violating any constraint. So this is degenerate basic feasible solution. So if I want to find out the minimum transportation cost now, okay, or basically we say instead of cost, I express this in terms of that you can say unit into kilometer. That means kilometer, cost will be proportional to that. This is not exactly the cost in rupees or something, but it is proportional to transportation cost, or you can consider these many unit cost. Okay, so 610 Patna to Lucknow, 610 into 2000, amount is 2000, 1060 into 1000, 1910 into 6000, 1150 into 4000, 630 into 1000, 1500 into 1000, and 0 into 3000, because dummy doesn't require anything. If you do that, this calculation, please check it yourself. If I have done any calculation mistake, you can rectify yourself, but in my calculation it is coming 20 lakh, how much, not 20 lakh, 1, 2, 3, okay, 3, 4, 5, 6, 7. So this is a कई 250 का 1000 10,000 लाख 10 लाख करोड़. So 2 crore 47 lakh, okay, no, this is this one, okay, 1 unit, okay, this is 10 to power. So you can say that 1, 2, 3, okay. Let me express in the form of this one, 20, 1, 2, 3, 4, 5, 6, 7, 8, okay. So 20, okay. So 20 crore, and then that 2 crore, okay, 2 crore, and if I say 40, say 4 lakh, and then 70,000. So you have say 1,000, 70,000 and 4 lakh 2 crore. Okay, so that is what that this one are approximately basically 1, 2, 3, 4, 5, 6, 7. 2 into 10 to the power 7 approximately. That much has come. So therefore, in the exam, or if you have to do quickly, many times we just write, instead of I would have done, instead of having the supply everywhere like 3,000, 6,000, 4,000, 5,000, I would have said that okay, supply is 3, 6. Later on I can adjust. Okay, I would have said that this is the supply is this much only, and I could have solved that in order to avoid the big numbers. Okay, otherwise you have to do this one. So I could have done that way also anyway. So what happens that for m sources and n destinations, there are m plus n constraint equations. However, as transportation model is always balanced, number of independent constraint equations is m plus n minus 1. It means that starting basic feasible solution should have m plus n minus 1 basic variables. A degenerate basic feasible solution, okay, in linear programming is one where at least one of the basic variables in the basis is equal to 0. In a non-degenerate basic feasible solution, all basic variables are strictly positive. So previous example shows degenerate basic feasible solution. Okay. Now how to resolve degeneracy? So I said that otherwise what method I suggested, that if you have that type of situation that you have to cut basically supply as well as destination. So don't cut both together, you cut only one, then this problem will not come. So degeneracy may occur at initial stage or at subsequent iterations. To resolve degeneracy, we make use of an artificial quantity, say epsilon or d is equal to 0. The quantity d is assigned to that unoccupied cell which has the minimum transportation cost. Okay, we can do that also. Okay, later on, that is this that way also it can be done, or in northwest kernel method I can just give to adjacent kernel. So here that suppose we have this one 610. So if this type of situation has come, in fact one can decide to give this one also, that here suppose one gives that this one and this one. So it can be called a basic feasible solution. Okay, that type of thing is there, but we will see that later, that whether it will create any other type of problem during the optimization. But usually if I follow the procedure of the Taha and I strike only 2, so suppose we keep moving one step either down or this one. So here from 2000 to 1000 I went, then I went to 6000, but here suddenly I had to come this way. So it is better that I give 0 here, and I come down here and I can give 0 here, then it becomes this one. So I need not give here. Otherwise, keeping the least cost one, I can give 0 here and I can 0 here. So that is the least cost, but least cost is another method also which will be coming that thing. Okay, that means you can do that. Okay, so next, so let us summarize that everything. So northwest kernel method, this method starts at the northwest kernel cell of the table, that is variable x11, we can say. Step 1, allocate as much as possible to the selected cell, as much as possible. Adjust the allocated amounts of supply and demand by subtracting the allocated amount. And step 2, cross cut the row and column with 0 remaining supply or demand. It indicates that no further assignment can be made in that row or column. If both row and column net to 0 simultaneously, cross cut only one, leave a 0 supply or demand in the uncrossed out row or column, that you can do that. And in step 3, if exactly one row or column is left uncrossed, then stop. Otherwise, move to the cell to the right if a column has been crossed, or the one below if a row has been crossed out, and then go to step 1. That means you keep doing that till you complete your assignments. Okay. So, this is given in the book of Taha. So, that I have explained you this one, and thank you very much for your attention. Now, in the next class, I will be discussing another method to make the basic feasible solution, and that is least cost method, which is much more efficient. Here you note down the cost, and you will see that in the next method how much cost came. Here it is cost is coming 2 crore 47 lakh 2 crore 4 lakh 70,000. Okay, 2 crore 4 lakh 70,000, but in the next class you will see that how it will get reduced. Thank you very much. Okay.